Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Well, good evening, everyone, and welcome to the event horizon here on Astronomy.FM radio. It is another Friday evening. This one is March the 2nd, 2018, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal Time puts it Saturday morning, about 2 o'clock in the morning, March the 3rd, 2018 again. So that means, yes, we are live. My name is Marty Kunz, and my co-host is...
Good evening, it's Nick Evetts, 2 Echo 0 Lima Uniform November, or if I'm in Wales, 2 Whiskey 0 Lima Uniform November, believe it or not.
And don't forget to come on over to our chat room. Go to the homepage where it says at Astronomy.FM. Look in the top where it says Radio Chat. We're reading that right now. I want to say hi to everybody in chat. We got Optronics, Starstorm, Glenn, Black Projects. We got
Marty,
yes.
You forgot to introduce somebody else live. Come on.
Hello, everyone. It's Starstorm.
I was getting there. I was saying,
waiting for her cue to say hello.
Starstorm in the background.
Yeah. Oh.
Well, checking the old internet, it seems like it's been a slow news week.
Mm-hmm.
Maybe month too. Nothing much happening on the sun. There was a decent active region, but no spots. Yeah, I don't know. It's like it seems really quiet. I checked on meteor shower. No meteor showers this time of the month. Regular sporadic stuff, but yep, no major meteor showers coming up right now. Not till we get into April, and I think it's the Leonids are coming up. And so that's kind of slow. I did see Venus this evening.
I didn't see anything this evening apart from grey clouds.
We actually had some
snow.
Yeah, I had a big snowstorm that you're getting now, and we got some nice clear weather right now. We're pretty much at full moon, though, so kind of bumps out. It is full moon, so kind of bumps out deep sky observing and meteor showers and all kind of stuff anyways. It's like, what's going on? But I did see it driving home, as I know it's low on the western horizon. Just after the sun goes down, it starts getting dark. My local time, I think it was about 7 o'clock. And I know Mercury is right next to it. It's like about 2 degrees, something. Sorry, 2 degrees, degree and a half, something like that, next to Venus. It's going to be that way for the next few days. So good chance to go look for Mercury because it's close to Venus. I thought it was too faint to see. I don't have a magnitude for it, but binoculars for sure. So find Jupiter first, and then look for Mercury right next to it for the next couple of days. If you got some clear skies, it's a great time to actually go see it. It's kind of a rare thing, even for seasoned astronomers.
Okay, let's do it. Let's do this week's Sky at a Glance, shall we, from March the 2nd to the 10th?
Sounds good to me.
Okay, this is an article by Alan McRobert. It's in Sky and Telescope magazine. Thank you, guys. It's so lovely to use this. Okay, so Friday, March the 2nd, soon after sunset, which is probably a big joke in the northeast at the moment. Use binoculars to start looking for Venus and Mercury together just above the west horizon, as shown in the diagram. And if you're in the longitudes of North America, check in on Jupiter's unusually great red spot with your telescope before dawn tomorrow morning. The GRS should cross Jupiter's central meridian around 6:12 a.m. Eastern Standard Time. That's 3:12 a.m. PST. Saturday morning, features on Jupiter remain close to the planet's central meridian. I'm still loud. And than to the limb for nearly an hour before and after they transit. You'll also find Ganymede's black shadow crossing Jupiter's face from 4:29 to 6:15 a.m. Eastern Standard Time. That is 1:19 to 3:15 a.m. PST, Saturday morning. Okay, all of the great red spots transit times in March, they come around every 10 hours, are listed actually on page 50 of the March edition of Sky and Telescope. It's only fair I put that piece in because this is their article I'm using.
Now, to see that, do you have to subscribe to the magazine, or is it available for non-subscribers?
The link I'm using is available for non-subscribers.
Great.
So basically, they actually have an app on their website that will show you all of this. So instead of go into the main skyandtelescope.com website. I'll just quickly come out of the article for a few seconds, and it's going to be under. Let me just quickly. It's under resources and education and interactive tools.
Great.
Okay, so these are mostly Java type apps, but they're very, very useful. In fact, I'll be honest, I've got a couple of them on my phone, and you can always run them on your computer.
Mm-hmm.
Oops, slight the wrong way with the direction arrows. Let me just flip the article again.
The other up.
So, yes, the article. So, Saturday, March 3rd. Today is when Venus and Mercury appear closest together, low in bright twilight, as per the middle panel of the article. Now, that's early March. Now, it's early March. Quite soon after dark, Ursa Major stands as high in the northeast as Cassiopeia is in the northwest. Midway between them, as always, is the pole star Polaris. Sunday the 4th, have you ever seen Canopus? It's the second brightest star after Sirius. In an interesting coincidence, Canopus lies almost due south of Sirius, or Sirius, by 36 degrees. That's far enough south that it never appears above your horizon unless you're below latitude 37. That's southern Virginia, southern Missouri, central California, and you'll need a very, very flat southern horizon. Canopus crosses the south point on the horizon just 20 minutes before Sirius does. When to look? Okay, so Canopus is due south when Beta Canis Majorum, the announcer, the star is about 3 finger widths to the right of Sirius, at its highest point due south, about 7 or 8 p.m. Now, depending on how far east or west you are in your time zone, look straight down from Marsium. Then, Monday the 5th, after dark, Orion's near horizontal belt points to the right towards Orange Aldebaran in the west, and further on, the little Pleiades star cluster is suitably glittering. You might not guess it now, but the Pleiades are heading down to its twilight rendezvous with Venus in 7 weeks. They'll pass each other for a few nights around April 23rd. Tuesday the 6th, Jupiter and the waning gibbous moon rise in company around the middle of the night tonight. By early dawn on Thursday, they hang together in fine view in the south. So if you do have a chance to get out and see it, please do. Wednesday the 7th, with the moon out of the evening sky, this is a fine week to look for the zodiacal light if you live in the mid-northern latitudes. Now, that the elliptic tilts high upwards from the western horizon at nightfall from a clear, clean, dark sight. Look west at the very end of twilight for a vague but huge, narrow pyramid of pearly light. It's very tall and very tilted to the left, aligning along the constellations of the zodiac. What you're actually seeing is sunlit interplanetary dust orbiting the sun near the epiliptic plane. Believe it or not, seen from interstellar distance, this could be the solar system's most prominent feature after the sun itself. The zodiacal lights of dust and around other stars may be a real obstacle to someday seeing their small terrestrial planets. Oh, what have you been tempted with? You want to see southern skies again, do you, Marty?
Yes, yeah, definitely want to again.
Okay, so Thursday the 8th, Orion is beginning to tilt westward after dark now. Later in the night and later in the month, he turns down further, putting his 3-star belt into its horizontal springtime position. Last quarter moon, exact at 6:20 a.m. March the 9th, Eastern Standard Time. The moon rises around 1 a.m. tonight. And in another hour or two, since it's high enough, you can see that it's to the right of Antares and above Mars. Which brings us back to Friday the 9th. Bright Sirius stands due south on the meridian just after twilight fades away into the night. Sirius is the bottom star of the equilateral winter triangle. The other 2 stars of the triangle are Orange Betelgeuse to Sirius's upper right, Orion's shoulder, and for Scion to Sirius's upper left. In the early dawn of Saturday, the moon forms a low flat triangle with Mars and Saturn, as shown in the bottom picture, and that would be looking south-southeast. And of course, March the 10th, on the traditional divide between winter and the spring sky, lies the dim constellation Cancer. It's between Gemini to its west and Leo to its east. Cancer holds something unique. It's the Beehive star cluster, M44, in its middle. The Beehive shows dimly to the naked eye if you have little or no light pollution. With binoculars, it's easy, even under worse conditions. Look for it a little less than halfway between Pollux in Gemini to Regulus in Leo. And of course, daylight saving time starts at 2 a.m. Sunday morning for most of North America.
That's in March or April?
That's in March.
March.
That's what they say.
March, what's daylight saving time?
I'd say March the 10th.
March
the 11th. So it's March the 11th that daylight saving starts.
Oh, that seems early to me.
It does, doesn't it? Yeah.
Yeah.
I've never known Scan Telescope to get it wrong.
I know. I have to double check that on some other reliable websites like the Daily News or something.
Daily Inquiry, yes.
There you go.
Just about as reliable as walking through a puddle with a hole in your shoe.
There you go. Oh, I see so many posts from people and stuff, and like, oh yeah, that post was fake, from Facebook and stuff. That post was fake 5 years ago, and somebody revamps it, puts it out there, like, oh, spectacular things have been found, and like, yeah, no, they haven't. I pretty much check and verify all my resources that I see on the web now, especially like on somebody posts something on Facebook that seems kind of sciencey, or is sciencey. I always try to double check it. Sometimes I know there's like, what's it, physics.org or something like that. Yeah, sometimes they're like a little on the edge of not quite right.
Starstorm has put some interesting links into the chat room for ESA, the one you usually put in, yes. Now, I'm actually saying that I actually went and did a quick bit of Googling. According to NewYorkUpstate.com, it indeed does start at 2 a.m. Saturday, March the 11th.
Wow. Okay. It's good to know. So Don't forget, everybody, after that time, we will be an hour forward, an hour ahead, right?
Yep.
So
springs ahead, falls behind.
Yep. So you have to adjust your listening time to everybody else will listen to it an hour early. Is that correct?
Well,
it'll be 1 o'clock in the morning.
The following week. So the following Friday, we will be on daylight savings. But you know what? I don't care because I'm on universal time anyway all the time on the computer. Well,
I just trying to remind everybody listening in on what time to listen in here. So
yeah.
So for those of you at 2 o'clock in the morning in the UK, will at least for a short time listen in at 1 o'clock in the morning, and then your British summertime kicks in, and then it's back to 2 o'clock in the morning, I think.
Well, according to this, the reason this happens is the U.S. Department of Transportation, which oversees time zones and daylight saving time, says daylight saving time saves energy, reduces traffic fatalities, and reduces crime. So the current DST configuration, second Sunday in March to the first Sunday in November, was established in the Energy Policy Act of 2005.
Okay. Saves... reduces crime, huh?
That's what they claim.
Now,
It's
light
politicians, after all.
Light pollution advocates have always shown that most crimes actually occur during, like house break-ins, occur during the daytime.
Yeah, in fact, if you use Amazon a lot, it happens all day, every day.
When nobody's home during the daytime, that's when most crimes happen, and that's why they're always countering, got to have these blasting streetlights out there to chase away criminals. It's like, well, no, people generally don't break into houses when they think there's people in there. They want to break into houses when they know nobody's in there, like during the daytime when everybody's at work or something like that. So it's like, I wonder where they're getting their crime data from.
Well, they all make it up anyway, Marty. Come on.
Oh, there you go.
Now, having said that, I've been reminded something. Now, actually, yesterday I bought a new atlas.
You bought a new atlas?
A new atlas, yes. It's an atlas of lunar landing sites.
Paper or digital?
It is paper.
Okay.
It's a traditional one. You can get it as digital in the instant PDF version.
Okay.
So this is what I actually went and bought. It shows all the lunar landing sites from Luna 9 through to Changi 3.
Okay.
Now, as Starstorm points out to me, it actually comes with three other atlases actually. So and those are actually Opportunity, Spirit. What was the other rover? Curiosity. Thank you. Ooh. So you can actually follow exactly where those wonderful little robots have been on the face of Mars too.
Nice.
And we're gonna need to know this stuff if we go to fix them up.
As you can see, I have a fan of the Martian rovers who thinks we should fix them up when we go there and put them back to good use. I agree with it, actually.
Well, isn't there at least one Humpty Dumpty robot on there?
Pardon?
Isn't there at least one Humpty Dumpty robot?
There's the Phoenix lander, which is in one location. That was never planned to move. The other thing was
that's the one that's splattered because of metric American difference.
No, Beagle. Unfortunately, the reason it didn't succeed was the fact that when it landed badly, and
basically just trashed it.
It trashed on the landing.
But we could still go there and repair it.
Well, there was one that. Trying to remember, was there a couple of them that had issues? One that crash landed because it thought it was at a higher altitude.
Oh, yes.
The difference between metric and American standard.
That was the one. That was the test one.
Okay.
I want to say, can't remember which mission it was. It was fairly recently. They were testing some new concepts for landing probes on Mars, and they kind of got it wrong. And unfortunately, the system thought it was at a predetermined altitude, and it jettisoned the parachutes. The engines cut in, but because it was still too high up, it
ran out of
fuel and pancakes. Yeah.
Okay. That was one glitch. There was another mission though that it was a matter of somebody programmed the altitude or gave it wrong instructions in like kilometers instead of miles. I can't remember which one that was. Which one was that? It just went splat.
That was the test bed one. Because
was it? I thought it was another one. Maybe some of our people in the chat room will.
Yeah, we have a question in the chat room.
Okay.
Let's talk Spirit. Can she be rebooted?
Spirit's is the one that's stuck in the sand because it was Spirit and Opportunity that went together pretty much, and Spirit got stuck. Opportunity still cruised around. So that one, might be revivable. It's just basically ran out of power.
So basically, they really need to maybe clean off the power. I think one of the issues was that the solar cells were completely covered, and I know that was potentially an issue with another probe, but they actually put a little vibrator unit into it, and it just enough to jiggle it, so that the sand actually bounced off.
I think, wasn't at least one of them hit by a dust storm?
Yes.
A dust devil. Yes. And it actually cleaned it off.
Yes. So that was a very lucky thing to happen.
Mm-hmm.
So Spirit got stuck in a place where she couldn't get enough sunlight to recharge a bit. It's kind of the Philae story all over again, really.
Mm-hmm.
Philae, the little probe that could, but got that they miss.
All right, what was the name of the comet?
Name of the comet.
Uh-huh.
Oh, something Karamensko. It's the Rosetta mission. Exactly. I hate that particular. I hate that one worse than I heard.
Churyumov Gerasimenko, and I did not look it up.
Yeah,
67p.
I hate that one. I hate that one worse than I hate 29p. Schwackman. I never get it wrong, and Michael always used to tell me off.
It's not Wachman.
Churi-guri, yeah.
It's not Schmackman, it's not Wachman. It's not Churi-guri.
But I hate CG with a passion because I can't always quite remember that one, and I'll get my numerals mixed up on it too. Terrible.
I get it now. I get it. Pretty good. Yeah, I think Spirit got stuck in sand. I think what they were doing for a lot of maybe those two probes, they were parking them on an angle on a little bit, slope sideways, so it would actually tilt them into the sunlight for the wintertime, when the sunlight's really low. And if they're on a flat or if they were tilted away from it, tilted towards the north, for instance, in the wintertime, that it wouldn't get enough sunlight, so they would park them tilted into the sun. And Spirit just got stuck in some flat, soft sand, so not enough sunlight was actually hitting the panels to charge the batteries up.
Right, now Black Projects has put a link into chat. It was the Mars Climate Orbiter, formerly Mars Surveyor 98 Orbiter.
Yep, Schiaparelli.
Yeah, basically the Schiaparelli experiment was a test bed. It completely and utterly screwed up. But the thing was, having said that, as the ESA text pointed out, they learned so much from all the mistakes.
Mm-hmm.
Well, yeah. It was a test bed. It was pretty much expendable anyway.
Right. It was.
But learning from those mistakes means that when we go for the major mission spacecraft,
we don't make them again.
We don't. Yep. Thank you, Starstorm. We don't make them again. Theoretically. Well, there's always the human element and human error.
Mm-hmm. Schiaparelli was expendable.
Yeah.
Landers. It was supposed to just do something, and then a week later it was going to be dead anyway. So not that big of a deal.
Pretty much, they wanted to try a new landing technique.
Mm-hmm.
They wanted to try, I think it was a new drill or something. But the whole point of it was to be one of those interesting little. Let's see if this works, and if it doesn't, we haven't really lost anything.
Right.
And I think that was the most important thing.
I think it was one of those here, hold my beer type of landings.
Aqua for you is commenting saying maybe obviously I need to speak Russian. Churi-guri indeed. Yeah. Well, like I say, some of us we have pet names for comets. Those of us that spend so much of our lives looking at them or imaging them anyway.
Did you say you want to start learning Russian? Was that you?
No, that's not me. That was Optronics earlier.
Okay.
And Aqua for you saying he obviously needs to learn to speak Russian. What is happening is when I get to go back to the UK for my visit, I'm going to be going back to college, back to university basically for a while, get my planetary science degree. Now, my course counselors, being the wonderful people that they are, and have suggested that I need to take on maybe one or two, maybe three languages, because they're saying, as a professional, once you finish your degree, you're a professional astronomer, even if you haven't got a job.
Mm-hmm.
However, that means you can now put in personal requests for time on whichever instrument has just been commissioned by the Chinese, the Japanese, or the Koreans.
Mm-hmm.
So they're saying, to be honest, Nick, and you need. They were telling all their traditional students the same. You really do need to have at least basic conversational Chinese, Japanese, and some Korean. Because that way, when you go to request your time on their instrument, now bear in mind the Chinese have put a huge radio telescope into place. They're working on their own optical instruments. The Japanese have built the Subaru telescopes, and one of which is in Hawaii. But in a lot of the cases, they are still controlled by Chinese or Japanese universities.
Mm-hmm.
And the thing is, if you're able to at least be nice and ask them face to face, can I please use your instrument for this? Because you
want to be careful how you ask that.
Oh, yes, you have to be very careful with Chinese because it's a very tonal language.
Mm-hmm.
You can say one thing, meaning you're asking for permission to use the scope, and if you don't use the right tone, you can really start an international incident. It's right. A bit like letting Jeremy Clarkson go to the EU. as a British government spokesperson. Sorry, I had to get that one in. But seriously, I know over here things like astronomy tend to be BAs and stuff like that. But in the UK and in Europe and a lot of other places, it's a Bachelor of Science. So they're saying now, let's have, why don't we start getting our BSc students into foreign languages, so that when they go abroad, if they go to say, if I was able to go to China for 3 weeks to use this telescope, I would be perfectly able to look after myself, because at least I know I'm able to ask for the right things and ask for directions.
There you go.
And the other side of it, for these people who've done these instruments, it gives them great face. It gives them great honor, personal feeling that they're being respected. And I think this is the thing we really have to remember. Astronomy is an international thing. It's not just Brits and Americans. It's Italians, French, everybody is involved. And if you're going to be working with foreigners, with astronomers from other countries, learning some of the language, just getting the basics, enough that you can politely ask for food, drink, or whatever, it is always a great idea, because then you're not dependent on translators who may occasionally mistranslate for the fun of it.
Mm-hmm.
And just to have a joke so they can have a laugh with their fellow countrymen about, oh, this scientist fellow who's come to use our wonderful piece of equipment and he can't even speak our language. Mm-hmm. All right, maybe I won't be able to read Chinese properly for a very long time, the same with Japanese and Korean. But the fact that I can actually make the effort to ask them and to talk to them and to communicate with them in their own language means at the end of the day, I'm more likely to get the time I want on their equipment, whereas some guy who walks in and says, "Hey, dude, I want to use your telescope," they're gonna even if he's got a couple of £1,000 for the time, or
Mm-hmm.
a couple of $100,000 for the time, who do you think's going to get the telescope time? The guy who spent the time to learn the language, or the guy who comes in doing, "Hey, dude, I want to use your telescope"?
Mm-hmm.
They'll probably just take his money and tell him I'll come back next week and maybe we'll let you on. Whereas I probably just got the access I want because I've made the effort to fit in with the people who provide the equipment. Mm-hmm. And I think this is something that's probably going to be very important, certainly on international space missions. I know that the American astronauts who go up to the ISS via Russia get at least basic Russian. They're taught the most important signs to be able to read in Cyrillic, and they're also taught enough Russian to get by without creating an international incident. So maybe this is something that really needs to come down into the universities and maybe into college and maybe even high school, is take a language and don't be afraid to go for something very difficult and very different. My daughter, she took French and she did very well at it.
I at least remember enough to get by.
Yeah, that's the important thing. She remembers enough to get by. Having a language when you're involved in science, particularly international science or maybe international space travel, is going to be very much a very needed thing. And of course, it means that when things go wrong, you can at least communicate. And you can figure out the issues and get everything sorted out. I know we're a little bit off the subject of astronomy, but we're not really, because it's all about education. And I think
Start a basic conversation.
exactly, you can at least start a basic conversation when you're doing an observation run, or maybe when you're traveling to and from the ISS, or maybe to some of the new habitats that are going to be built beyond high Earth orbit.
Mhm.
The moon is definitely going to be opened up. The Chinese want to go there. The Russians maybe will go there as part of an international project. Certainly Mars, I believe, will be an international space project. No one country is really going to be able to afford to go to Mars in a big way. Yeah, back up for you to put something into chat in Cyrillic. Science is how we are all connected. That's a very, very true point. We are connected internationally with science, and the fact,
Not just astronomy.
and it's not just astronomy.
It's medical technology.
Yeah. But as I say, the important thing is don't be afraid to go for something and at least try and do it. At
Shoot
best,
for the moon.
shoot for the moon, exactly, because you never know. You may actually succeed.
Among the stars.
Succeed and find yourself out amongst the stars. Thank you. And
You might actually miss the moon and ask for help. Need to ask for directions.
No, that is the Starman, who's as everybody knows, Stig's spacefaring cousin.
There you go.
Okay.
Still a little station identification. You're listening to the Event Horizon here on Astronomy.FM, about halfway through our program. So somewhere around 9:30 in the evening, Friday evening, March the 2nd, 2018, also known in Universal Time as Saturday morning, 2:30 in the morning, March the 3rd, 2018. Also, so we're halfway through our program. Still got another half hour or so of our live presentation here. Don't forget, we'll repeat this program with other programs every 4 hours for the next 24 hours. So stay tuned, listening in after the Event Horizon for more programs. And if you miss some of it, you can always catch us in the repeats a little bit later. But this is the time to come on over to the chat room. This is when we watch the chat room during the program. So if you have any astronomy question, come on into the chat room. And you can get there by going to our homepage, Astronomy.FM. Look where it says Radio Chat. Click on that. Type in a name. You don't have to do a password. Skip the password. Ignore it. Just hit login, and you'll be here in our chat room. More than happy to have you here, and just if you want to just pop in, say hi, and leave. That's good too.
Yeah.
Do like to know if you want to tell us about where you live, what country, what state, whatever. That's always fun to know where everybody's typing in from. You mentioned we were talking about Curiosity.
Yeah.
Well, they figured out a way of getting the drill to work.
Yeah. Good.
They had problems with the drill. The drill was working pretty good up till like October or something like that. Then it jammed up. The drill is a little bit unusual. It's kind of like it sticks out on the end of an arm, and it's kind of like holding a drill press in your hand. So you hold it out, set it down on the ground, and then pull the handle, and the drill extends down. Well, the drill on Curiosity is similar to that in that there's two arms or two pins that come down first, so it kind of steadies it, and then the center drill comes down and drills the hole. Well, it got jammed up somehow, so it wasn't working. Well, they did come up with a way of leaving the two pins retracted and getting the drill bit to stick all the way out, and they're just going to leave it like that. So you can drill that way, but the problem is it's hard to drill really straight that way. And if you don't drill really straight, you can jam your drill bit in the ground and get it stuck. And if it's attached to the rest of your probe, yeah, you're either going to rip the arm off trying to get out of there, or going to damage the whole arm or something like that. So they figured out if they do it carefully, they did some tests with a one they have here on the Earth. So they kind of rigged it up so it worked like the one on Mars. If they drill really slowly, there's some torque sensors on the drill, so they can tell if it's starting to jam up. So they can move the arm or maybe move the wheels a little bit and change the angle of the drill so that it's not binding up. If you think about, if you just hold a drill out at arm's length and pull the trigger, it basically would go in a radius. It wouldn't go straight down. It would go in a little bit of a curving arc. Well, if you go in a curving arc, you're going to jam the drill. So they figured a way that they can actually adjust the tension on the drill bit so it doesn't jam up and lock in. So they went down about a half inch so far. It must have been a really slow process. That half inch, I would imagine, probably took an entire day to drill that way, because they probably had to drill it down, check the sensors. You know, it's like a 20-minute round trip both ways. So 20 minutes there, 20 minutes back as far as communications go. And then they would have to adjust the tension, drill a little bit again, and then wait 40 minutes for, response. So it was probably a really slow process at first to figure out how to do it. But they do think they can start drilling in that modified way back in the surface of Mars and get some analysis of what's inside there. Now, what's the angle on my drill bit? It's always crooked. Let me just put it that way.
One of the things I was going to say was going back to Foote and Rosetta.
And what's the name of the comment?
CG. You ain't going to get me that.
Share your mouth, Grasiminko.
Anyway, when little Foote was actually using the drill it had.
That was the lander, by the way.
That was the lander, yes.
Two-part mission, one orbiter, one lander. Philae was the lander.
The interesting thing was that they started off very, very slow and easy, and it didn't do anything. So progressively, they actually, I think, quote one of the people involved, they cranked it up to the point where they had actually had a red line on this thing that they weren't going to go beyond.
Mm-hmm. And
they decided that, okay, this is getting a little bit better, we're getting somewhere, but they were getting very close to where they weren't supposed to be going. Mm-hmm. Somebody said, well, what the hell, let's do it. And they did. And they actually started drilling into the crust of the comet. Finally, they had to really take it beyond the normal safety parameters that they'd set themselves. But that just shows you that sometimes if you take yourself too seriously and you set yourself to too low a target, perhaps, as being a danger level, you just don't get the things done. Science, yeah, you have to take it seriously to a point, but you should always keep yourself open to new ideas, I think. And a lot of people don't. They have their set idea. It was like with the moon, everybody thought the craters were caused by volcanism. Now,
most everybody,
a lot of people did, including Patrick Moore for a long time. But when they actually started looking at it in a different way, they started realizing that all the lunar craters could not have been created by volcanic eruptions. Now, we know that the mare were actually created by basaltic lavas pouring out, but it wasn't just terrestrial volcanism involved. There was the actual impacts. The impacts alone, in a lot of cases, were melting rock, and particularly in certain craters with you see a peak in the center.
I'll do that now because I'm going to shut my show down soon.
I think I just heard our production controller then. Oh boy!
I didn't quite hear it.
There's something about shutting the show down soon. Anyway, the thing was, the actual peak was formed by the splash of the molten material. Now we're getting towards a point where we believe that the moon was created by a planetesimal that struck the Earth, the early Earth, and the material was dislodged from the collision came from the Earth, and maybe Thea, as it's been called, that is now being challenged again. So saying that this is the right theory and this is the right way, and I don't care what you say, is stupid, because you're never going to really do effective science if you blink it. Now, as I say,
the ancient collision thing was getting challenged because it doesn't explain the entire composition of the moon like that. So I can't. What was the latest one that was just like out a couple of weeks ago?
I think it's similar to the
yes, similar,
but they're seeing a different mechanism.
Mm-hmm.
I haven't actually had a chance to read that story yet. As soon as I do, I will save it and we will discuss it on the show. Or if I find it before Wednesday, I will bug you and Diane with the story.
Okay, I remember looking at that story, and I can't remember where it was or what the details were on it. But
But as I say, it's the whole lunar evolution thing literally has evolved from being outright volcanism to being what we are considering today, which is the impact of two bodies, and now that was what caused the moon to be created. Some people actually thought it was created by a huge asteroid impacting into the Earth, and another bunch thought it was created by tidal spinning and material being stripped off the Earth by a tidal bulge. That one, I think, has been pretty much destroyed and shown to be completely false. So that one's definitely gone out. One
of the original ideas was that basically the moon and the Earth formed at the same time from material. They just basically got two lumps circling around each other early in the beginning of the universe, and one was the moon, one was the Earth.
Well, that's another one has been discredited and put away into the cupboard of. Yes, it was a brilliant idea, but it doesn't quite work, does it?
Right. Well, what's helped change that is analysis of the lunar material.
Yeah.
By sending astronauts there, bringing back samples, analyzing the samples, and saying, nope, if this was going to work this way, we would not be able to find this material there. Exactly. So that's pretty much what changed the whole idea of how the moon formed. And again, it didn't the small planet impacting the Earth. Again, left a few things out where it didn't quite explain all the materials.
But having said that, with the similarity of isotopes and rock types, to be honest, finding orange soil on the moon was kind of a major clue by four that we have something here that's unusual, and the fact it led to the moon being closer to the Earth in its origins than previously thought. I think that, as you say, the lunar rock samples really helped kill off quite a few way out theories about how the moon formed. The thing is, we know it's relative. We have the age pretty much pinned down to a good degree. It is consistent with the age of the Earth, so we know that the Earth may be slightly older than the moon, but the problem is the geological record on Earth is constantly being plowed over. And there's a few places left in the world where you have the really most ancient Genesis rocks left, and some of these rocks are where they started finding the correlation between the lunar samples and good old Sol 3.
Mhm.
Up, and there's a link there. You put a link in.
Yep, a link in on the latest moon origin hypothesis theory. Let's see.
Has it formed inside the Earth when it was a spinning cloud of vaporized rock? Explains some of the features that are hard to resolve with current ideas. According to Sarah Stewart, professor of Earthplanetary Sciences, UC Davis. Yeah, it is. There is pretty much chemically the same as the Earth. There's some differences, but that's explainable through solar radiation bombardment to some degree, because that is going to change the elements. Now, as I say, the commonly accepted theory was that a Mars-sized body collided with the proto-Earth, spun material into orbit, that settled down into a disk and accreted to form the Moon. The body that was left after the impact was the Earth as we know it. That's been the canonical model for about 20 years now. But it's taken so long to get there. But the thing is, even Professor Locke says that this latest theory is probably not correct either. So it's the first model that can match the pattern of the Moon's composition. It shows that the isotopic fingerprint for both the Earth and the Moon are nearly identical, but it does suggest they came from the same source. So it looks like there may have been a situation where there was a collision. It's possible that that's still part of the creation of the Moon. And just trying to see what else they're saying.
It kind of like goes way down there and gives you little bits at a time.
Yeah.
It doesn't like give something like, here's the exact idea of what we're thinking about. No, it's just kind of hinting at what it kind of sort of might be kind of ish like if it was sort of like this somehow. So slightly different idea of how the Moon formed. You can read the article in more detail.
Oh, yes.
And talking to the audience out there and get an idea what they're thinking about. So that would explain, this new idea would explain a little bit more of the chemistry of the Moon and the Earth a little bit better. They're talking about like basically sort of a donut-shaped ring around the Earth that might have been part of a collision and part of the original formation, but the donut-shaped material some of it would have gone, basically donut-shaped gas cloud and dust cloud would have gone down towards the Earth, and the Moon would have picked up a bunch of the rest of it too. So there's a picture here.
Yeah. But the thing is, it's interesting to see where things are going. We are getting more and more willing to consider different hypotheses about the creation of the Moon, which means in turn we can re-examine things like our definition of a planet. Pluto is a planet still. I was born into a universe where we had 9 planets.
Blah blah blah.
But the thing is, though, Marty, according to the IAU definition of a planet, it has to clear its orbit completely. That means that the Earth fails.
Did it say completely or majorly?
Well, the way they're saying it has to clear its orbit. Now, in that case, the Earth fails the definition of a planet because we have objects in the Earth's orbit ahead and behind, as well as the Moon. So therefore, the Moon isn't an issue with the definition of a planet, but these objects that are trailing front and behind the Earth, Trojan asteroids, means that the Earth has not yet cleared its orbit. Therefore, like Pluto, it is not a planet.
I get a feeling they well, at the time they already knew that, Jupiter had asteroids, and it's those Trojan points too. So I think they would thinking that would majorly clear its orbit, not 100%. I mean, there's constant dust and debris, like you talked about the zodiacal light, stuff like that. There's constantly stuff throughout the whole solar system, and it's be rejuvenated, so that nothing can perfectly clear out its entire orbit forever.
I think what they're trying to say is there should be no major debris left in the planetary orbit.
Right.
So things like Trojan asteroids or centaurs should not be there. But the thing is,
I don't know.
The problem is, Jupiter has at one point cleared its orbit, but it's a major attractor.
Right.
It's like a vacuum cleaner.
A vacuum cleaner in space. How would that actually work?
How is your Schwartz?
It would be a gravity cleaner, not a vacuum cleaner. No, actually, it would be a gravity cleaner that cleans the vacuum.
Because the thing is, Jupiter does one or two things. Either it removes objects, particularly the odd comet, asteroid, or whatever that might come hurtling in towards us, or if it's feeling mischievous, can actually kick them into us. So either way, Jupiter, Saturn, and I'll probably say Uranus and Neptune, all affect the orbits of detritus in the solar system. Now they can either kick it out of the solar system, or they can pull it into the inner solar and send it into the inner solar system. Now, we know Mars has got craters. Why? Because what's the first thing the probe started showing us when we actually successfully got there? I think it was Mariner 9. The first image you sent back by its fax machine was craters on the surface of Mars. Everybody was gobsmacked at that one. Didn't see that one coming, did they? Schiaparelli had his lovely, wonderful canals. His Martians were pumping water all over the planet. It's an optical illusion. But the thing is, we found out now that Mars is quite heavily cratered. Probably more so after the atmosphere was leached away to a higher degree. But obviously, even when Mars probably did have a decent atmosphere, some of the larger stuff would have still got through. We know that happens. Why? Because we have places like Chicxulub, we have the Windsor crater, we have Barringer crater. There's so many. There's quite a few other craters all around the world testify to what happens when we get a very large piece of rock or iron nickel come through the atmosphere that doesn't burn up.
It'd be interesting to see if somebody figured that out. If Mars had a heavier atmosphere, obviously it would have made more meteors burn up during the heavy bombardment time. But then as the atmosphere started dissipating, it would not slow down or burn up the meteors that were in, so it would let more in, but at a time when there was less meteors or asteroids to hit it. Well, I wonder if anybody's got that one figured out.
I don't know, but what I can tell you is we know that it had the reason we know there was an atmosphere once and now it's gone is because magnetically speaking, Mars has a very weak magnetosphere. It's almost pretty much gone.
Well, there was water there too, so
yeah.
If you got water, you've got an atmosphere.
On the surface, yeah. So you have to have a reasonably dense atmosphere to have liquid water on the surface. So we know it was there. We know something happened to Mars's core, and that cost it its magnetosphere. Once the magnetosphere goes away, then the solar wind starts ripping away the atmosphere. So after a while, you're reduced to what Mars has now, which part of the reason it is so difficult to soft land rovers. Now, obviously, we had no problems landing the Viking probes, and we probably heavily contaminated the landing site too. But luckily for us, they didn't find any surviving bugs when they went to do their tests, because they just probably didn't have enough time anyway. What would happen if we were to go and swab the Viking probes now? Would we find mutated Earth bugs? Quite possibly. We know that there are certain strains of bacterium which are relatively immune to cosmic radiation and can survive in space. So it does mean that it does open up the window of opportunity for some things to have hitched a ride to Mars from Earth to survive and maybe adapt and flourish again.
Maybe there's some Mars degrades there.
Who knows? Maybe even tardigrades.
No, they would be Mars degrades.
Let's go tardigrades first. But the thing is, as I say, it has a relic of. We know that it was there because we know it had an atmosphere. We know what happens to planets who lose their magnetic fields. The atmosphere goes. Mm-hmm. So one person had this clever idea, maybe using nuclear weapons to restart it. I don't think he should be taken seriously. I think he should be tied to a gun wheel, and we know what he would do to those people.
Well, what you have to do is make like a Vulcan, hand sign, and put that onto the control panel. Mars will get an atmosphere again.
Temporarily. It'll still be a temporary one.
Yeah, but it'd be for now, though.
It probably lasts, maybe 200 or 300 years?
Oh, no, Mars, no. Tens of thousands. I thought if you put an atmosphere on the moon, I remember reading it should be able to stay there for about 1,000 years before it gets too thinned out.
But then again, we also know that the moon did have a magnetic field. The core is pretty much cold. Mm-hmm. Therefore, that's the important thing. You have to have a hot liquid core to have an effective magnetic field for your planet or moon.
Yeah, it helps.
It helps majorly, Marty. Trust me.
Because you read it on the internet.
No, actually, I read this in a book, very good book, talking about. It was a geological book. It was talking about the fact that the Earth has its magnetic field because of our liquid core. Therefore, we know that other planets must have cores. In some cases, they may be warm and still producing a residual field, or if they're cold, then the field's gone. It does dissipate. But the thing is, geologically speaking, the Earth has a strong magnetic field because we have a liquid core, a molten iron core. Mm-hmm. That's what that, and the interaction obviously with the solar wind and everything, that gives us our chance to live. At the end of the day, it's the Earth's magnetic fields that actually gave us the chance to live, because otherwise the simplest chains would build, they get to a point, solar radiation would intervene, destroy them, and then they're back to square one.
Yeah, kind of a combination of everything is needed, really.
Oh, yeah. It is a very large number of things that are needed to have life. Mm-hmm. I wonder how many places perhaps had life that never got beyond the basic stage because there was no protection.
Mm-hmm. I've been to some of those nightclubs. They used to have life.
Yeah, I know a few of those places too, Marty, in my youth. I was a student many years ago.
There you go. Got an occultation of the moon, and I think it's Gamma Libra coming up March the 7th, visible from western U.S., western Canada, and Alaska. So get to see.
If you want a good calendar for lunar occultations, go to the Moon Appreciation Society on Facebook.
There you go.
Because they have a really good, excellent one. And okay, Marty.
So none of you, dark sky astrophotographers should join that group.
Well, it's that time, folks. We're getting to the end of the closed show. It is USS Miranda. We have 3 members of the away team to beam up, and it's been a really nice mission for a change. I have to admit that. Captain, we're ready to come home.
All right, thanks everybody. Appreciate you all being here. Everybody that's been in chat room, appreciate that too. Thanks for joining us tonight. Don't forget, we'll repeat this program and more programming coming up for the next 4 hours, and repeat them every 4 hours for the next 24 hours. Good night, everybody.
Energize.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing.